okay? So a couple things to keep in mind first, right? That when we're in mathematical modeling now, for those that are FBM majors, right? A previous student told me about this. So I'm gonna say, keep in mind here. We are shooting for a profit loss statement. Now, if you're not FBM, that's fine, but I'm sure that you may have taken a class here or there at FIT where it discusses this. And so we're going to say profit loss statement. And here in parentheses, I'm just going to write FBM terminology. Again, it's not exclusive to FBM. It's just most of the FBM students told me, they're like, oh yeah, it's kind of like that, right? And all you need to remember is the expression will be an expression of income minus expenses. I rarely use red, as you all know, because it kind of scares people. Hold on, I'm going to mute whoever this is. And then this is defined as your model, at least for our class, right? So that means that whenever I say, hey, make a model, what you're essentially making me is a profit loss statement. And a profit loss statement is, of course, made of things that make you money, income, minus things that cost you money, in this case, expenses. So this 3 equal sign, right? It's just not a typo, it's defined as, or defined by. Okay. And in fact, let me double check that. 3 lines in mathematics. Or identical to. Okay, that's good. Yeah, it's defined as or identical to. You know, I should fix that. If you didn't write this part down, that's fine. But this is identical to identical. If you're curious, I believe defined is that one, actually, equal sign with the colon, but that's whatever. You don't have to worry about that. But yeah, is identical to. So in other words, whenever you hear that phrase, right? Hey, look for the model, make the model, whatever the case may be. Your model is going to consist of multiple things that make you income, as well as multiple things that cost you, in this case, expenses. And then the profit loss statement is a model, in other words, right? So that's what's happening. And then what happens is that when approaching the model, right? When approaching any model, at least for this class, you want to think these 3 steps. Okay. Number 1, why is everyone not understanding how to use the Zoom link? Okay. When approaching the model, you want to think in 3 steps. The first one is that whenever you see these problems, and again, if you're looking at the same time the email that I sent last night, you'll see that there'll be steps or pieces or numberings or parts, however you want to think of it, where they describe things. And then I couldn't draw a dash because it was just Blackboard. I composed the email on Blackboard, so it's kind of like whatever. And then what happens is that sorry. I'm just gonna write this out, sorry. I'm gonna find or solve the components or pieces that make up the model. So the idea here is that if you ever played with Legos, or if you never played with them, but you at least know what they are, what happens is that you're going to have multiple pieces or parts, right? And they will either involve little calculation, a lot of calculation, no calculation, and whatever you arrive at, those are the little pieces that you're going to be putting together in terms of building blocks to make up the entire model. So I'm not sure if you've ever seen a Lego instruction book. You don't just build from step 1 all the way to step 678 type of thing, right? Sometimes depending on how complicated your Lego whatever is, right? Like they say a copy of the Manhattan skyline or the Eiffel Tower in Paris, or whatever you're building in terms of Legos, right? Whatever interests you. Sometimes what they do is they split it up and you work on one piece. So then once you're finished one component of it, they'll call it like, say, hey, this is part A, you will. And then what happens is that you move to the next instruction. And then what happens is that you are working on a new piece, and then it's going like step B or something like that. Why is everyone emailing me right now? Okay, sorry. It's too many people to ignore. Okay. Why is everyone all of a sudden brain dead from spring break? For those that are already in class, you could just delete the email I just sent out. Okay. Whatever. See, man, they're killing me here right now. Okay, I forgot what I was going to say about that. I mean, I know I was talking about Legos, but whatever. Okay, here's the second step. Second step is that once you find all the pieces, right, you use those components to build or construct the model. So what happens here is that once you have all your pieces, what happens is that this is just a matter of putting everything together, whether it's adding all your incomes together or adding all your expenses together or subtracting off all your expenses from whatever is making you money. However, the common mistake, as you'll see, is that when you make the model, in other words, you write it out for me, you just want to note that this is never, as far as this class is concerned, never solving for a single solution, right? So it's an expression, right? It is an expression, algebraic expression, to be specific, not a number, not yet at least, not a number. So your model, whatever it is, whatever problem you're working on, should never be a single number. So never a number, it's an expression, right? Algebraic expression. And then once the model is constructed, built, or whatever you want to call it, then you answer the follow-up questions. Answer follow-up questions. Pertaining to model. So it's quite simple, right? You just do first step, second step, third step. The thing to realize though is that for whether it's the first or the third step, right, there will be multiple parts, of course, because you can't have the model made up of just a single concept. And when I make follow-up questions, you're not going to just answer one question. That's not enough, right? It's not enough learning. It's not enough application. It's not enough fill in the blank, however you want to think of it. Too easy, right? Okay, so if you look at your email that I sent out last night, you didn't have to do anything about it. It's just having it there for easy reference. You don't have to sit here for 10, 15 minutes to watch me write it out, type it out, whatever the case may be. I'm going to go directly off of those problems, but I may not just write out everything in terms of the wording, right? So the problems that we're going to do now, the first two examples for the day, at least I pretty much end on those two examples because they're quite long, but they might be a lot faster this time with it written out without having you to watch me type it out. We might even move a little bit quicker. But the questions are in your email, and let's see if I can pull it up as well. Yeah, so you have, we're going to say example one now. Why is this doing this? Okay. All right. So I remember now. We're not going to just start with those examples right away. I'm just going to do a little baby example right here. So this one I will type out, but it's really short. So example one. This is a baby example. Baby example. So say you had something that was written like this. We have finances approaching for the month of May. And then you have the following. We have a goal of $250,000 to meet by putting money away every month. You make $30 an hour. And you have a one-time deposit of $500. Okay, and then the leading question is, how would you represent the above for the month of May? Now, the thing though is, when you're reading this question, it will be phrased more or less the same every time. All you need to know is basically, this means, make me the model, make me the model. Okay. Okay, so then if you follow these same 3 steps right here, right? 1, 2, and 3. Well, what's 1? 1 first says you're going to solve, quote unquote, or find the components that make up this model. Now, before everyone goes into super panic, obviously, hopefully you realize that this isn't a full-fledged question, right? Not all the details are there. You have a goal of $250,000, you can see putting money away, so you should know it's annuity, but I didn't give you a, for example, interest rate or length of time, because it's a baby example. It's just, you're wading into the water first, right? Just tiptoeing in to figure things out. So just remember that your model itself is, again, comprised of things that make you money minus your expenses. So what are they, right? If you want, you can always list them out, but here I'm going to number them. So we have a goal of $250,000, and we're going to put away every month. So say that's 1, right? Well, that's an expense, right? And then you make $30 an hour. That's the second piece of information. That's making you money. So that's 2 right there under income. And then you have a one-time deposit of $500. Well, if you're depositing the money, you're depositing it into somewhere else. You're not making that money, right? Or if you want me to be more specific, you have a one-time deposit of $500 to pay, right? But the intention is that that $500 deposit is another expense, right? So your model, again, made up of income minus expenses. When you read this, right, there's information missing. However, that's not the point. It's just understanding, oh, what things, when you read out a paragraph, cost me money, what things make me money. So doing all this in light blue, that's all step 1 right here, right? Step 1 is identifying your pieces and knowing what it is. Now for step 2, right? How about the model itself? Well, the model itself, if you're making $30 an hour, you might write something like 30x, right? And then under the income, you would say x equals hours worked. Okay. And then now you have to subtract off your expenses. So if number 1 was this $250,000 that you have to put away every month, that's some kind of recurring payment. And if it's a goal, you know it's going to be a future value. And then this last one is this $500 right here. Right? So this would be the quote unquote model that I would be expecting in this particular problem. And again, notice how the model itself has no single number, right? This is an expression, an algebraic expression that has multiple parts. Some are constant, some are variable. But the thing is that you're not solving for a single number, right? It's an expression, it's an algebraic expression. It's not an equation, because remember, equations need to have equal signs. Well, this model doesn't equal anything, right? I mean, if you really want to, you could, I guess, write this as equal right there, but it's not really, right? You're not saying that a model is another variable. This model is this expression is the model. So it's not an equation. It's just an expression that's supposed to be representative of this month of May for this example right here. And then you can see there's no follow-up questions. But if I asked you, hey, suppose that your Suppose this number was, say, I don't know, $50. How many hours do you need to work to, make a profit from your model? That's one example right there, but I didn't write it out formally and you don't have to worry about that. The important thing is to, for this small example right here, is to identify each component, whether it categorizes in income or expenses, and then can you put it together, okay? Now we can move on to the first example that I emailed yesterday. So emailing yesterday, it says that, suppose you have the following details for your business, right? Revenue is generated by 5 times the number of employees. You have a goal of $1 million over 30 years at 4.52% compounded monthly with monthly deposits. And lease to your office is $250,000 at 5% over 20 years. Okay, this is example 2 now. So what I want you to notice is that those first 3 bullets, right? 3, 1, 2, 3. Yeah, those will make up your model. That's equivalent to the 1, 2, and 3 that I circled in light blue here that we're going to solve, AKA find, right? And then you can see, even though there is a 4th bullet right there, it's just a leading question, right? How would you represent the above monthly situation? That's finding the model. But what I really want you to point your attention to is that if you notice the ABC underneath, where I'm asking the questions, what is the outcome of the model? If you have 10,000 employees, blah, 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 so on and so forth. The most common mistake students do is that they start pulling information from those questions to build the model. And that's absolutely incorrect, right? I have it listed in this bulleted section or bulleted fashion so that people realize that, oh, the first so many bullets help me produce the model, construct the model, make the model, whatever your favorite verb is, right? You can't answer questions about the model until you have the model. So you should not even touch the whole, what is the outcome, suppose for the 2nd month, suppose for the 3rd, like none of that should be touched right now. So we're doing the first 3 bullets now, right? So I'm just gonna, I'm gonna label it. So here's the first bullet. And it says that revenue is generated by 5 times the number of employees. Well, that's easy enough at least. You can just go let 5x be income, where, whoop, that's not how you spell where. That's not how you spell where either. Where x equals number of employees. Some students in the past ask, oh, do we have to write all this out? Yeah, you do. If you remember writing proofs at one point or one stage of your academic career, right? You have to label things, right? It's not a matter of just X, right? That's insufficient, if you will. It's like, it has to be more. So you have to tell me what you're doing, 5X, and then you got to tell me what X is. Now, what's the piece, if you will, that you're going to use in your model? It's going to be, let's put a circle instead, right? It's this 5X part right here. Oops, right? That's going to be one of 3 pieces, okay? I'll color code so it'll help too. So here's your second bullet. The second bullet here tells us that we have a goal of $1 million over 30 years at 4.52% compound monthly with monthly deposits. So you already know that this is going to be not only an annuity, it's a future value because there's a goal, and you're solving for the recurring payments. Okay, now this is the only problem I do, at least for now, to show you this, but something that I'm going to nag almost every one of you because it was an issue of having to go back and giving points back. I don't mind doing that, But when people are making mistakes that are unexpected, then it's just kind of super disappointing, right? So if it wasn't obvious already, this is the equation we're going to be using. Most people got that correct. This is in reference to the second exam. Nope, that's wrong. Okay. We're told we have monthly deposits. People got that correct. People also knew that we were looking for whatever variable you're looking for. Most people got this right, knowing that it was $1 million to start with. I'm just using these numbers from our example as a problem. But when I said, hey, in the instructions, write down the variables as if you would plug in to the annuity, I got this as an answer. That is not an answer. That is totally wrong. Do we ever use a percentage version in the formula? No. Some people wrote me this. Okay, I gave partial credit for that. Is that the right way? Nope. Because what are you missing? You're missing the CP, right? Now, whether you wrote CP or 12, I gave you 4 points for that, right? But if you wrote this first way right here, you're in super trouble. You must know. I mean, and yeah, you can argue like, oh, but I know what to do on the paper. Well, if you know what to do on the paper, why would you write it that way on the test, right? Same with this right here too, right? You know that if you're using the interest rate, you must divide by the compounding period. So you'll hear me nag this if I hear this often, but I'm not going to say the same exact thing for this. This is for 30 years. So it had to include the CP. It was insufficient to just have just the number of years. Because if you had an exam like that where I say plug in the numbers, why would I ask you that? That's the numbers already given to you in the problem. You know, that's kind of like asking a question and having the answer in the question already, right? In any event, you're set up for this. And it wasn't just your class, the other class did it too. It's just bloody annoying. Right, you can see right here already. Oops, that's supposed to be 12, right? The number is always divided by the compounding period, in this case, the interest rate. 1 plus 0.0452 minus 1 for 12 and 360. So you do this, right? I already have the calculation in advance. This number turns out to be, where is it? $1,377.73. Okay, so now this is a second component. Oh, that's not what I wanted. There we go. This is a second component to our model. Okay, that last one, the third bullet, is a lease. And hopefully you remember that the lease implies that it's a present value annuity. And then since they gave you the total amount, you're solving for the recurring payment. Now, I'm not going to list all the variables again here, but I will write down the formula for you really quick with the numbers plugged in, give you the calculation, and then we'll be good to go there. And then I'll show you how it all comes together. And then for anyone that happens to be coming in late, remember these numbers are given to you because the problems were written out in advance, so you don't have to worry about writing all of this. And I'm wasting your lecture time by just having you sit here and watch this. So that's why I decided to do it this way. And this is how I'm going to do it from here on out for the rest of the semester, so that you don't have to worry about extra writing. I'm just sitting here watching you write. And this is minus 240, right? So this is a setup for the third bullet, right? That's that whole, let me pull up the question again. $250,000 lease for your office, 5% over 20 years, okay? And then this number ends up being recurring payment, and it will be $1,649.89. So everything up until now should be review more or less. Okay. Now, how do you put it all together? I'll pause for a moment here. And what have we done so far, right? I'm gonna scroll to what I wrote here earlier, is that when approaching any model, think in 3 steps. We find or solve the components or pieces that make up the model, right? And then we have multiples here. So we just finished this first step right here, right? And then if you're looking at the questions again, right, notice that how we didn't talk about the outcome if there were 10,000 employees or supposing for the second month or the third month or anything of that nature. We're not touching any of that. We are still just making the model. So now we're getting to step 2. We're going to construct or build the model with what? With the 3 components that are circled here, this 5X, this monthly payment to make $1 million, this monthly payment of our lease. So what's making us money? In the textbook, when you start reading it a little bit more, this isn't required of everyone. It's just that I've done it for everyone. I will always show on the textbook your model in terms of a symbolic representation. And those are for people that like to just use the variables to get their thoughts out. So if you wrote this as the model, that'd be correct, because that's exactly what it is, right? 5 times the number of employees, you're subtracting off the recurring payment for whatever the future value goal is, in this case, $1 million, and you're subtracting off the recurring payment for your lease, right? Most students, however, as you can imagine, they write the model numerically. So with numbers. So numerical. So in other words, you have 5X, and then now you just fill in those numbers that I circled here. So the 5X was from the first bullet. This one we're subtracting off, again, 1,377.73. And then we're subtracting off this last one right here, which is $1,649.89. Okay, so no matter which of these models you provide, whether you go the symbolic route or the numerical route or numeric, right? Both of those are correct. Again, it's unnecessary to have both. However, again, some students prefer the first method with the symbols because it organizes their thoughts. They're able to distinguish the components easily. And then what happens is that they can attack it right away. Some students, they say, you know, forget the symbols. I'd rather just get all the calculations done. And then they put in the models with their numbers. And this is what may confuse students sometimes too, because when they arrive at the model, they think that they're supposed to be solving for something, right? Don't write this down, but they think like, oh, this is equal to 0 or equal to some random number or some figure. And then you're supposed to figure out and condense this model to a single digit. That is not the case, right? We're not even there yet. So these 3 pieces, black, purple, and navy, they're made up from calculations. Yes, were there calculations? Yeah, but they were things that you've already worked on. And they make up the model, okay? So I'll pause for a moment here, see if there's any questions here on this part right here in the chat section, which there doesn't look any, okay? What questions do we have up to this point so far? Because now we're gonna answer the questions after that. And if you don't want to talk, that's fine. I'm just going to check the little chat room here. All right, good. Now that we have our model, we can now answer those follow-up questions. So again, referring to that email, right? What is the outcome of a model if you have 10,000 employees? So this is questions now. And there's 3 types of questions. We don't see all of them here, but we'll see them on the next lecture, whether you're coming Friday or we're doing this for Wednesday for sure next week, okay? So for number 1, this is a calculating question. Why is it a calculating question? We provide, or I provide, that X is equal to 10,000. Well, what are you gonna do with this 10,000? Oops, too many zeros, right? You're gonna plug it in. You're gonna take this 10,000 and you're gonna plug it in right to where you see an X in your model. And then you just solve, right? Now there's a solving or a simplification aspect to it. So it's just 5 times 10,000 here. And you're gonna subtract off your other expenses, minus 1,377,73, minus 1,649,89. And then you find out that this will come out to, have the answer right here, $46,972.38, which is a positive outcome, right? In other words, we made money for this first month. The calculating based questions that follow up from the model, those are the easiest because I give you some kind of number and you plug it in, and as long as your model is done correctly, you'll get the right answer. So that's straightforward. Okay. The thing that you want to note though is that as you move to the second question right here, I'm going to give us a little bit of space because I'm going to notate it here. So here's question number 2, but first I'm going to note that obviously this 46,000, nearly 47,000, that's a net in your favor, right? For this fictitious business that you have. You made $47,000 in the first month. However, you want to leave calculated values isolated between months. Right? In other words, AKA no carryover. In profit. So I'm not saying that you lost this money, right? When you're focusing on question number 2, when I'm talking about supposedly in a second month, right? Is that you don't want to add this to your model because then it just complicates things. So you want to make each calculation or manipulation or theoretical question, those are the 3, by the way, I'll write them down, don't worry. You want to keep them separate of one another. Now, there may be changes to the model. Those changes you carry over because it's easy to change from the base. But when you add too many components, then it gets a little bit daunting, exhausting, right? So in other words, this 46,000 or nearly 47,000, you want to leave it here and you're done. Now, when we go to question number 2 and it says, hey, suppose for the second month, assume all the components are the same, but now the income is generated by 10 times the number of employees. What does the model look like? You now have a base model to look up. Right? This is your base model. Not only is this your model, this is your base model. And I said that everything is the same except for this piece right here. Instead of making income that's 5 times the number of employees, you go by 10 times the number of employees. So you write down second month's model. You know your expenses are the same. Minus 1,377.73 minus 1,649.89. But now, instead of moving from 5, we were told that it moves to 10. So I'm going to change that for green now. And then that's the model that I'm looking for. Now, some students in the past, they like to explain this in words. They don't always have to do the algebra because maybe they're more articulate in their writing, right? So I would say, normally I would see responses like your income doubles in capacity, and then that implies overall increase in model, right? So there's something to be aware of here as well. Again, you could do either of these. You don't need both, or, right? But the thing is that realize that the model itself, right, it increases. You go from 5 to 10, you double it. But that doesn't necessarily mean that you'll make more money, because if you don't make enough of this X component, whatever it is you're talking about, obviously you'll be at a loss. So there's a difference, there's a difference between the model increasing as a whole. That's what I mean by overall increase in model. But that doesn't always imply that you're going to make double your money, right? So you want to make sure you just state the things that you need to their respective pieces, right? You're not saying that you're going to double money. It's that your income doubles in capacity, right? And then you're not going to say that you have an increase of automatic money, because that's assuming you're going to always make money, which you want to, of course. However, you can't assume that, because, you know, it's real life and all that fun stuff. But you can say that it's an overall increase in the model structure, because you had 5x and then now you're at 10x. And then the constants, they stay the same. So that's not changing either. Okay. So this would be considered what I would call not a calculating, but a manipulating question. So manipulating, because you're manipulating the base model to get whatever your next models are. Okay. For the third question, I'm already going to tell you right now, it's also a manipulating question. It's just a little bit different, right? So it says, suppose for the third, we have an additional one-time expense. You need to make $500,000 via single deposit at 7% compounded continuously over 40 years. What is a single deposit and how does the model look like now? So number 3 here, I want to scroll down. This is also manipulating. And then what you have to realize is that you are adding on an additional expense, right? What are the key words for that additional expense? Let's write this in a different color. I'll write it in pink, right? It's a additional one-time expense. Okay, and before I move on, student in the other section yesterday asked, well, wait, so when I do this model for the third month, do I need to change this 10x back to 5x? The question is no. In short, it just depends. If I tell you to revert back in my little tiny story in these problems, like say I go, oh, you made less money and you felt like you had to furlough employees, so you couldn't rely on your revenue based on 10 times the number of employees. You got rid of some, so you reduced it back to, you predicted to be 5 times the number of employees. Yeah, if I tell you to go back, go back. But otherwise, you move from model to model, from month to month. So in other words, this first month right here, right, we use the base model right there. The second month here, this has changed just to 10, right? From 5 to 10, constants stay the same. Okay, for this third month right here, you're going to see that there's an additional piece right here. And as you read on, you notice that it says compound what? Compound continuously. So you should already remember that you're using this formula. Okay, and why is it this formula where we're solving for the deposit? Well, they told you that you have a goal of, hold on, how much was it? $500,000, right? So I'll write those details for you down. There's $500,000, and we're doing it for 7% over 40 years, right? This is going to be the additional component. I don't know what this answer is, so let me do this really quick for you. E to the 0.07 times 40. Okay, there it is. So here's 30,405 and 0.03, so that's 3 cents. Okay, so this will now become our additional component or piece to the model. So what's going to be the third month's model here? I'm going to write it down here on the bottom. Third month's model. And you know it's going to follow the same format right here, right? See where this orange box is here on top? Right here? Right? We're going to drag that down and we're going to add to it. So then we still have that 10x, as I was mentioning earlier, right? We don't revert back to that 5 unless you're told otherwise. Okay? Your monthly expenses are still the same, 1,077, 73, as well as the lease, 1649.89, 1649.89. But now you have this additional 30,000, 405.03. And that's the answer I would be looking for this third month right now. Another thing is that students may ask, oh, can I combine all the constants? In other words, why is this doing that? May I or can I hate this box so much. Okay, there you go. May I combine all the constants? In other words, the numbers that don't have variables, the purple number, the navy number, and now this green number, right? Or in other words, the recurring payment for your future value, your recurring payment for the lease, and now this one-time deposit here. And the answer is yes, you can. However, I think it's easier to keep them separate like this unless you need to combine them, right? Because when you go from these boxes, right? So even though I didn't box the first one, but see, there's your base, right? There it is. It's kind of like your template, if you will, your financial template. And then the first question wasn't changing it. It was just a calculating question. But the second one manipulated it. See how it changed from 10x from 5x? And then now we have that same exact one right there, but now we had an additional detail right there. So you can see that when you keep things separate like this, it's easy to see the change from month to month, okay? And then if you're curious, I'll just type it out really quick here, even though we didn't have it in this problem. You don't have it in the second problem either. Note, the third type of follow-up question is theoretical, right? In other words, I'm going to be asking you some type of hypothetical situation, and you can show it by calculating or manipulating or something like that, but it's going to be more of a thinking process instead of something that's rote as in calculating. All right. So as I promised, like most students said, and I'm sure the entire class agrees, that this problem, it's lengthy. And imagine if it was longer, if you had to sit here and watch me type it all out, the questions at least. So that's the nice thing about being online is that I can just type them out really quick, email to all of you, and then you can rewrite it. Rewrite it in advance or before class, or at least have it up for reference. What questions do we have there? I'm gonna flip back really quick to Zoom to see if anyone's gonna type a question for me right now. And that's pretty much what we're gonna be doing for the entire semester, right? If you have a question about, say, the first exam or the second exam, or you might go, hey, I wanna see this type of problem. Obviously, I'm gonna do said problem. However, in terms of class and homework moving forward, when you're practicing for the final, I'm going to give it to you in the form of a model because one, it's what the class is called, mathematical modeling, right? In a true sense, not just your baby sense where it's like, here's a linear model. I mean, here's an example. It's linear. Isn't that cool? Here's an example. Oh, it's exponential. Isn't that cool? It models your situation. That's the most rudimentary way of thinking about it. And you've already done that. You've done word problems in the past that simulate that. This is more than just a simple word problem, right? It's a breathing, evolving template that is supposed to dictate and it's also assist you in terms of how you're having these finances from month to month. Yeah, these are more business mind frame, or if you will, or business like. However, it's supposed to help you in terms of understanding, if you will. Okay. What questions do we have there as I check really quick for roll call, if you will? Jocelyn, Judy, Janet, May, Celine, I saw Michael's name too. Is Michaela here? Yes, she is. Franchelli, is Jessica here? Yes. Asia, I saw. Tiana, cool. Is Greg here? ABCDFG. Is Maxwell here? Yes, he is. All right, cool. All right, so for those that came in and you missed the beginning, don't worry. As always, the PDF will be on Blackboard via the link that says link to lectures. But remember, this video is going to be uploaded to YouTube as well. Of course, I'll trim the beginning and end so we don't have those extra questions pertaining uniquely to this class. All right. Since I'm not hearing anybody say anything, I didn't see anybody chat anything, let's move on to the second model. And don't worry, you're not going to do this on your own. I'm still going to walk you through it. But again, we don't have to write everything out. So here's example 3. Right, and you can see that it's the same vernacular more or less, but I changed things up, right? And remember how I said very briefly just maybe a moment ago or earlier in this hour that this is nice because it pulls all the review that we're going to be doing. That is that if you have an individualized question, you will have that individualized question. Otherwise, my review will always be in the form of a model. Well, if you read this, right, you suppose we sell movie tickets. You can see that first bullet right there. You sell 4 tickets for $100, 10 tickets for $250. Each ticket can be sold for $35. When you read something like that in 2 sets of pairs and you see that phrase, each ticket can be sold for a certain amount, hopefully in your head, you should be registering cost, revenue, profit just right from the get-go, right? It's how it's always phrased. You always have 2 sets of points and you always have some amount like that. Okay, and then you can see here that a lease to the office, so another lease problem there, another annuity. And then last but not least, you place an ad for your business for the first month for $2,000. Now, is that anything formally we've learned? No, of course not, but you have the algebraic or the mathematical fortitude to understand that that's just another constant of $2,000. And you can see that there's 4 follow-up questions after the model is complete, but remember, those 4 square bullets do not contribute to the model. Your model is made up of only those first 3 bullets. You do that and you make the model and that's it, okay? So let's start that. Let me scroll down to this question here. So the first bullet, right? If I had written out everything, you would have seen that I would have the numbers written out as points, but since I didn't, I'm just going to write it here for you first. So it was 4 and 100 and 10 and 250. So what do? Right? We got to find the slope between those 2 points and then find the equation between the 2 points and then all that jazz that we did way back when, right? So if you forgot already, that's fine. It's been a while, but here's your slope formula, right? Y2 minus Y1 over X2 minus X1. And then that's going to equal, in terms of color coding, 250, 10, 100, 4. So then this becomes 150 over 6, which will be 25. Okay, and then from there, we use the point slope formula, or again, as I've said many times in class, you can use the slope intercept formula to do it as well. It just depends on your personal preference of how you arrive at said equation, right? And remember, I always use the smaller of the number. So this 25, remember, is a slope. That goes right there. I'm going to use 4 right there and 100 right there. Plugging this in, right? We get y minus equals x minus, close parentheses. So y minus 100, 25, and then x minus 4. So again, I use this smaller point right here to plug in my values. So you do this, right? And then what happens is that you get a super simplified version of the cost function. And it's just 25x, right? What happens is that the 25 distributes, and then 4 times a quarter is 100, but then if you add the 100 over, it cancels out. So we normally have like +4 or something like that right there. But this example, I just made super simple, just so that we can get it out of the way quicker. And remember, this is an example that I would normally type out in class as well, so it's to save time. Okay, the revenue function, remember, is 35x. Where did 35 come from? That came from the whole each unit, or in this case, each ticket can be sold for $35. And remember, in any cost revenue profit problem, you must be given that sentence. Otherwise, you cannot do the problem, right? It's just the way it is. And yeah, that's pretty much it. You just plug it in. And then the last part is the profit. And then if you remember, the profit function is always made up of the revenue function. I'm going to scroll up now. The revenue function minus the cost function. Okay, in this case, it's easy. You don't have to worry about distributing the negative as you really had to in the past. So I'm just going to write right here, the profit function. What's 35 minus 25? That's just 10x right there. So the first piece of our model is this part right here. Okay, so you can see now that I can easily incorporate cost revenue profit to be your generating income for the model, right? Some students in the past might say, well, wait a second, don't we have to include all 3 pieces in our model, right? It makes sense in the real world that you have something that costs you money, there's something that makes you money, and then after you make the money, do you have a profit margin only? Yeah, it does make sense to have all 3. But we've already learned this concept where the profit is made up of the difference between the revenue and cost. So why do we need to add that in there? You can just add the profit immediately, and that's your income without having to worry about uniqueness to this problem, right? You don't want to be convoluted to just this piece. So we only need the profit portion, because that's the same thing as making income, right? It's just the pure money that comes into your business. All right, the second bullet here is another lease already, as I told you or mentioned. So I wrote this in black. Okay, I want me to write this in purple now. So your second bullet here is, again, a lease, which means a present value annuity. Right, lease means present value annuity, which means that you solve for R, right? And again, that formula is just this one right here. 1 minus 1 plus I to the negative n. And then you plug in your numbers, and they are the following. 300,000.
I just have a quick question about the leasing part.
Go ahead.
Will it, at least for the second bullet, will it always be like something like the lease and then you would allude to a present value, or will it be something like a mortgage or something? Will it ever be something other than a lease?
It could be a mortgage as well. The good news, though, is that between lease and mortgage, those are always present value problems.
Right.
Okay. In other words, what also may help is that whenever we do these models, when we talk about any kind of overhead, so some people, I'm not sure if anyone knew this, but if you start your own business and you work more than, I think, 60% of your time at your apartment, you can write off a part of your apartment as a business expense. In this case, it'd be housing overhead type of thing. So yes, the short answer is, yeah, it will either be a lease or a mortgage. And to further extrapolate that, if it's anything about overhead, I'm more than likely talking about a present value sense, because you wouldn't lease something but put money away for the future because you're leasing it now, if that makes sense.
Right. Okay.
Perfect. So 1 plus 0.0426 minus 420 and over 12. So I did this calculation in advance as well. This number is going to be our present value equals $1,375.51. By the way, if people are wanting to pause for a moment to make sure that they remember how to do these calculations, please say something, because otherwise I'm just going to move to the next bullet or whatnot. So hopefully people remember, or they're familiar enough to do this and not freak out, if you will. But here is the first and second bullet. But the third bullet, even though it is something I formally put in there, it's a simple one, right? It's that $2,000 ad campaign. So when you make your model now, and again, not required, but if you're going to do it symbolically, or symbolic, right? You're looking at the profit function minus whatever the lease is. In this case, you already know, and then minus that $2,000. Or you could easily have done the same exact thing. I'm just going to call this numeric really quick. Numeric, or numerically. So that's your 10x. That's this number that we just solved for. And then minus 2,000. And again, you can see we follow this pattern of having a base model, right? Whether it's with numbers or with symbols. But you can see the advantage of having the numeric one right from the get-go, because if you didn't solve for it now, you'll have to solve for it later. When do you solve for it later? When we look at the follow-up questions, right? The first question here, right? It already tells you what's the outcome of 50,000 tickets are sold. So if you did it this way, kudos, that's great. But then you don't know what this number is, right? Big question marks all around. It's like, well, what is this number, so that when I plug in 50,000 for X, I can actually get an answer, right? So let me just get rid of those pink question marks. But that's the advantage of running to the numeric question right away. But again, like I said, some people like to do the symbols and then they do the calculations on the side, and it helps them as well. What you want to avoid, though, is plugging in, what's the number again? 50,000. Yeah, you want to avoid plugging in 50,000 anywhere prematurely until you reach either this one or this one, okay? So in other words, question 1 here. This one is again, a calculating question, and they tell you that X is equal to 50K. So you just plug it in, right? It's pretty straightforward. So I'll just do this really quick. This implies that you're going to go 10 off the base model, right? So that's this one right here, times 50,000. And then you subtract off these expenses, 137,551 minus 2,000. As you notice, I'm writing a little bit sloppily because, well, we already have it written nicely above, so it's just the same numbers. This will give you, let me flip the page here for myself, $496, $624.49. Again, a positive outcome here. And again, you don't need both. It's just that for those that like to have both, or they like to ad lib in here and say additional details. But for a calculating question, you do have to provide a number, because that's what I'm asking. I'm asking for not only a positive outcome, but what is it? What happens when you sell 50,000 tickets? Now, there's no formal calculation on the second month, but I do bring it to your attention because I want people to pay attention to the fact that things change. So immediately I ask for the second question, hey, what does the second model look like? Again, you carry things over where are necessary. So second month's model here. Right, you know that, what different color, I'm gonna use this light gray here. You know that the 10X will follow again, right? You know that your lease will follow again. However, this 2000, nope, doesn't come over, right? I'm gonna draw a big red X here. This does not come over. Why? Well, not only was it stated that the $2,000 was for your ad campaign, it was an ad campaign that was happening only for the first month. So this is an example where you have to pay attention for how the pieces move or carry over or don't carry over in this case. So your second month, I wouldn't even call it a manipulation. It's kind of like a manipulation problem, but you manipulate it by eliminating that 2,000. So, if you're thinking, oh, is this supposed to be this easy? Yeah, it is supposed to be this easy, depending on the problem. It's to acknowledge how your model changes from month to month, right? You got a template model to work off of, and then you'll notice that moving forward, you may have a new template, right? This becomes your new template, your new base. Why? Because we're already done with that first month, and that $2,000 was an ad campaign that was in hopes to generate more money in the future, and it paid off, and it's a one-time investment and you're done with it, right? Maybe you'll come back to it again, maybe you won't, but it doesn't matter now because it's in the past. Sure, you have a record of it. That's why you started with that as the first model. But now you have essentially a new base to go for. Excuse me. Okay, so there's that. And then now for the third bullet, it says, you made a lot of profit since the first 2 months, right? You made that nearly $500,000. Wow, that's a lot of money from ticket sales. And then now all of a sudden you have a second month, and we didn't say how many tickets were sold, but now whatever you sold, that you have a gain of $2,000, or in other words, you have a $2,000 expense you no longer have to worry about. So I'm saying now for the third question, this hypothetical situation, that you have a third month's model, and they say you have a goal now of $250,000 in 20 years at 3% via single deposit. Damn, there's a typo in there. I forgot to tell you what the compounding period is. Since a lot of profit has been made the first 2 months, you now have a goal of $250,000 in 20 years at 3% via single deposit. Okay, yeah. I forgot to give you the compound period there. So there's not a typo in terms of something written incorrectly. It's just I omitted the fact that the compounding period is weekly there. So whether you're writing in your notes or you have rewritten the question, make sure to add that there's a compounding period of 52 there. I just forgot to type it. I omitted it by accident. Okay, but now that you know it's a single deposit and there is a compound period, right? This right there, compound period, it is a single deposit. You should realize that means you're going to be using this equation. Right? Because there is a compound period and it's a single deposit. It's not an annuity, right? Otherwise, it'd be multiple deposits as one of the questions for the exam, right? All right. And what's going to happen is we fill in these details right here. Don't use the same color. No, let's use a different color. Let's do navy now. So we got P equals $250,000 over 1 plus 0.03. And remember, this is compound weekly, right? So it's 52 here, and I did it in advance, and it's 1040 for the exponent right there as well. So that's good there. I do this in advance, and then this came out to, make sure I did this right, copy it right, 137,226.65. Okay. And then now we just have to tack this onto our model. So third month's model. We're going to go 10x, still the lease, 37551, and then now this new single time expense, right? How do we know it's single? We're using the regular compound equation instead of an annuity. Okay, and then something related to cost revenue profit that we haven't seen in a while is the fourth question, right? I ask you, what's the break even? Break even, remember, is that you have to set the model, to zero. Zero what? $0, right? People always get the zero correct, but then when they get their answer, they still think they're solving for money. But you can't solve for money if you're already telling me that you're making $0. So you can't be recursive in your answer. You can't use the same thing that was given to you and then all of a sudden say like, hey, it's my answer too. I have $0 and now I have a certain amount of money. It's like, it doesn't work that way. So again, here, you want to remember that this is $0 is equal to the model. Well, what's our model? Well, third month's model specifically. It's now $0 equal to 10x minus 137551 minus 137, ooh, that was messy, 22665. So this is an example where at this point, since you're going to be actually solving, there's an equal sign, it's a proper equation, then you can combine the constants, right? In other words, these two numbers right here without a variable, right? You add those two together, it's a bigger negative number, but then when you add it to the side, you'll divide by 10 and all that jazz, right? So these two numbers, when you add it together, negative, and it goes on the other side, it becomes 138,602.16. And then that's equal to 10x. But when you divide by 10, that's the same thing as moving the decimal place one spot to the left, right? So to divide by 10 is the same thing as making the number smaller, aka moving this decimal point one spot to the left. So this implies now that x is equal to what? 13,860.216. Is this money? Can't be money. We had $0 right here, right? Not money. Very critical there, right? What is it? It's X things. What were we talking about? We're selling tickets. So 13,860 tickets. But like I've nagged before, we're not going to leave it like that. We have to do what? We have to round up, right? Because you can't sell 0.216, round up to next whole number, right? You don't sell 0.216 tickets. You're going to sell 13,861 tickets, right? Not dollars, not anything, just tickets right there, right? And you can see I went through the lecture a lot quicker because you don't have to spend 10 minutes just me typing out these darn questions and eating up time like that, okay? So among this one, what makes this problem or this example or this model unique is that the first one was a little bit more straightforward, right? Whatever is generating your income, it's very linear, right? This is actually linear as well. It just requires a little bit more work because it's using the ideology of cost, revenue, profit. But you can see that if you're curious, those are the bullets. Question one right here, if you want to write this for yourself as well. This one was a calculating question. This one was a manipulating. So is this one. And then this one is, it's more calculating based, but you can kind of say it's a little bit of theory because you have to remember the break-even aspect, but I would consider it still more a calculating question right there. So you can see that these 4 follow-up questions, right? Even though they do involve the model, they do not contribute to the model. You must construct the model as I've written out here, first bullet, second bullet, third bullet. Get your model first, and only then you can answer these questions here. Okay, I know I keep on scrolling back and forth a lot, but just trying to show you the point without dancing here. All right, what questions do we have here?